Okay, hello. Right, this is on network topologies, so you need the PowerPoint and you've got some questions there as well. Nothing too major. Right, this is a fairly quick one. So let's make a start. All right. So topology. Well, a topology is just a layout of a network. All right. There's only two we've got to look at, so you probably did more at GCSE. The star and the bus network. All right. Now, local area networks, first off. Local area network consists of a number of computing devices within a single site or a single building. So LAN as opposed to a WAN, which is a wide area network. They transmit data very fast, but only over a shortish distance. And the two we're going to look at is bus and star. Now the bus topology, that's the first one. So let's have a... so basically what is a single line called the bus, and then we have computers connect to it. Okay. Now, and at the end we have these things called terminators. Now what I'll do is I will write this, screen capture that. Probably should have done this before, but and then right. So let's see how this thing works. Now, so what do we have then? Well, we have our computers. So these here are terminators. Now, in class, I would show you what those look like. Nothing actually as fancy as they sound, to be honest. It's just a look. And your computers at the end have like a T piece that connect to like that. That's the T piece. It's upside down T that connect into it. Now, this looks like pretty much like coaxial cable. Now, if you're wondering what coaxial cable, it's the same cable that you get from your satellite dish or TV aerial. All right, so it's quite a thick cable, not the type of cable that you would use to connect to your router, all right, which is twisted pair. So it's much thicker. Now, what happens then is that you send frames. Okay, so these are the things that we're sending down the network. All right, easy to confuse with packets that we send over wide area networks. So let's say that this machine here, this one, wants to ask the file server for a file. So it needs to contact it. All right. So what it does, it sends a frame. Now a frame, which we'll talk about in a minute, will get sent across both ways. It doesn't know where it is. So a frame will go past every machine. Each machine will have a look at it and go, right, is that for me? No. I'll have a look at this, because each frame will have a destination and a source and some data. Now the data will be a request. So as it goes along, it will then travel along here. Is it for me? No. Is it for me? So they go across everything. So it's pretty insecure. So every machine can see everyone else's data, though it should ignore it if it's not for it. And then it will eventually arrive. All right. So it's kind of like bi-directional, and that's all great. Now what also can happen is, before that computer here, this one here, decided to send, it would have listened to see if the network was free. If the network was free, it would have transmitted its packets. I said packets then, I meant frames. Now, what can happen is this, that this device here also decides, oh, I want to send, and it sends its frame as well, and we have a collision. All right, so that is not good, because that means that the data in the packet, or the whole packet, becomes corrupted. All right, so what they both do is back off. All right, they both say stop, and I'll wait a random amount of time before I try again. All right, so I'll go, right, okay, I'll wait, and then is it clear? Yeah, okay, I'll start transmitting. Okay, so it sends. This one then comes out of its wait state slightly behind the other one. Here's that someone else is transmitting, so it waits a random amount of time before trying again. Okay, now that's all well and good, but while both of these were waiting their random amount of time, this chap here could decide, oh, I'm going to start sending and then they come out of their wait states. They're waiting, they're waiting, they're waiting. So what can happen is it kind of snowballs out control. So under heavy load, this is very slow. All right. Now in terms of speed, top speed you get about here is 10 megabits a second, which isn't pretty, considering you can get one. College ones I think are 1 gigabit. Okay, which is much faster, obviously. So they were quite slow, but I mean it's very old. But basically, the whole basis of this is Ethernet. Okay, so this is Ethernet. So this was actually done quite a long time ago. It's probably 1970s. So the Ethernet is the basis. This was how it first started, and then they just changed the topology. Right. Let's go back to this. Right. So the advantages are, right, less cable than star topologies, doesn't require any additional hardware, such as a switch or a hub. Okay, yeah. So going back to that, there's only one main bit of cable running through the entire thing. Obviously you've got that little bit of cable connecting to your cable, and you have to break the cable as well in order to connect to it, but doesn't require much in the way of cable. Well suited to small networks not requiring high speeds. Disadvantage: the main cable fails, the whole network will go down. Now, I didn't mention the terminators. Now what the terminator does is when a frame arrives here, it stops it rebounding on itself and then causing a collision. So it stops it corrupting. So it kind of absorbs the frame as it hits the end. Now if there's a break here, and this is something students used to do, let's say that's a break here, then every frame now that hits that will rebound, causing a collision. So in other words, this entire network is taken out now, and you have to find out where the fault is. Limited cable length, number of stations, I can't remember how many it is, but it's limited. Performance degrades under heavy traffic, definitely low security, as all computers can see all other transmissions. Right, so how it works. So this is basically, I've already described this. So device wanting to communicate with another sends a broadcasting message, and let's see if now. Right, now it's called CSMA/CD. Okay, so carrier sense multiple access with collision detection. Now, so the carrier sense is the listening part. Multiple access means there's more than one device on the bus, and collision detection is that they're listening to hear if the packets actually collide. Okay. Now, one way around that is a star network. Now, what we have instead there is now each computer has its own dedicated cable to a switch. Okay, and then any one of these could be a server, and other switches can be connected or to other routers, to other networks. So the idea with this one then, now we're using a switch. If I want to send data to that computer, I send it, the switch will then know which port on here it's connected to, the other computer, and then only send it to that one. So it's not going to swamp the whole network with traffic, unlike the last one. Now, the other, you could use a hub. A hub is like a dumb version of a switch, which it would send it all to every other stations. Now, the advantage is if one cable fails, only one station is affected. So you know, if one of them is not working, you know which cable it is, unlike the previous one. Even consistent performance, you can get much higher speeds, no problems with collisions because each people have their own cable. More secure, easy to add new stations, so you can just plug in a new one. Different stations can transmit at different speeds. Yeah, okay, possibly. I don't really see that's a massive advantage. Costly to install. There's a lot of cable required. If the central device goes down, your switch or hub, then the whole thing goes down, but they're pretty reliable. The cable is obviously different. This is twisted pair, much thinner than your coaxial. Okay, now a hub will broadcast any frames it receives. A switch will send it to the correct address or the MAC address of each device. Now, a MAC address is a unique address for each networking device. So on your phone, you'll have a MAC address for your wireless card. You'll have one. You have a wireless card, but for your wireless, you'll also probably have a MAC address for your when you connect via the data network as well. So you can easily find out what your MAC address is. So network interface card has a unique media access control address, MAC address, and it's a 48-bit long, and it's written like that. So 1, 2, 3, 4, 5, 6 bytes. That's how you can see it. God, that's a really bad diagram, isn't it? But if you do ipconfig/all in let's say command prompt's now pretty much dead, isn't it? But what's it called now? PowerShell, same thing, it would work. Okay, so you can see that it's called physical address in Windows. Okay, yes, you can. There's even an option to do it in Windows. So the idea would be that the computers at college, for instance, they'll log what MAC addresses visited which sites. So, but it isn't foolproof because people can change the MAC address. I don't think you can on college computers easily. Okay, so there's some exercises there. Only 2, so it shouldn't take you too long. Okay, explain what event happens in a collision. So draw some diagrams, pretty straightforward. All right, okay. That is the topologies